Okay. So if I share, I don't know where I stop. Okay. So I hope you can hear me and you can see my screen. Okay. So so scatter plot, if you use scatter, okay, then you can see that corresponding corresponding amplitude level is marked here. Okay. To draw the signal, you need to join this point. That is how we normally draw a graph. Okay. Okay. So MATLAB, you can use another command, that is plot command. Okay. If you use plot command, okay. So this plot command, so in the same manner, first you have to write the corresponding time value, corresponding independent variable. So it is t, and dependent variable, that is x2t. Okay. So if I run this, okay, so you can see that now you can see that those points are joined. Okay, joined together. Then you can see uh, it look like a continuous time variable, continuous time signal. Okay. Okay. So now what is the problem with our one? So this is not a sinusoidal signal. It is just a normal signal. Okay. So what is the problem with that? Okay. So problem is, okay, I will quickly tell. Okay. Problem is, okay, so the frequency is 50. No, frequency is 50. That means what is the time for one cycle? Time for one cycle, what? So that is 1 over 50. No, that is 1 over 50. And 1 over 50 is equal to 2.02. Okay. 0.02. Okay. So this is in second maybe. Okay. Alright. So this is one cycle time. This is one cycle time. 0.02 second. Okay. So that means, okay, that means if you consider this one, okay, so 0.02, here you have one cycle actually. Here you have one cycle. That means like this you will have. And 0.5 another cycle. Okay. Another cycle like this. Okay. So if you take this time 0, 0.5, 1, 1.5, you are getting only the H value. Okay. You are getting only the H value. That is 1. Okay. Okay. You are getting this H value here. Okay. So you can't get the sinusoidal signal. To get the sinusoidal signal, what you have to do? You have to calculate this point. Now it is like this. Okay. I think you can understand what I'm saying. Okay. Okay. So we have a signal like this. Okay. We have a signal like this. Okay. So it is like this. So the signal should be like this. Okay. This is a cos signal, no? So the signal will be like this. Should be like this. Okay. Now one cycle. This is one cycle. This is a two cycle. This is one cycle is 0.025. This is 0.5. Okay. So this is 0.75. Okay. And this will be 1 like this. Okay. So it is on. Okay. So now you have take these time value 0.1, 0.5, again 1, 1.5, so on. Okay. And 0. So 0 corresponding value is 1. Okay. Then 0.15 corresponding value is 5. For 1 corresponding value is 1. For 1.5 corresponding value is 1. So okay. So it takes only these values, then it just join them. Okay. So you will get this kind of DC signal. Okay. So to get the sines wave, what you have to do? Okay, you need to get some point like this. Okay, need to get some point like this. Okay, within this 0.25. Okay, before this 0.25, you need to get some values. Okay, otherwise, it will not look like a sinusoidal signal. Okay, so I hope you understand it. If you have any problem, you can later ask me. Okay, so I quickly do it. Okay, so what I want to do is I need to reduce this increment. Okay, so I choose 0.1. Okay, so if I run this, okay, so what happened here again? 0.1. All these are one. Again, all these are one. Yes, again, these are ones. No? This is 0.2. Okay, sorry. This is 0.2. I'm sorry. This is 0.2. No? This is 0.2. So this will be 0. This will be 0.4. Okay. This will be 0.6. This will be 0.8, and that will be 0.9. Like guys. Okay. Uh, Zero point 0.1, it should be here. So it should be 0.2, it should be here. 0.3, it should be here. Okay. So these are the point calculated. So it cannot be 1 actually. What's happening here? Okay, it's happening. What is the problem with the program? So if I reduce this now, let's see. One over 50, it is 0.2, no? It is 0.02, 1 over 50. Okay. So if I draw the signal will be like this. Okay. Suppose signal, no? Signal will be like this. This is one cycle focus signal. This point is repeating here. And this point is repeating here. This point is repeating here. So on. Okay. So this will be 0.2. This will be 0.4. This point will be 0.6. This will be 0.7. So on. Okay. So this will be 0.5. 0.8. This should be 1. Okay, this will be 1. So if you get 0.1, it should be here and it should be here, no? Like this, you'll get. Okay, so I should have this kind of graph. So what is the problem? Can anyone see what is the problem? One minus one, 1 minus 1. Okay, it is correct. But when I draw, what happened? Now it is okay. No? But, if I put here, sorry. If I put 0 point, I'm sorry. Previously I used 0.5, okay? 0.5 actually. So 0.5, I'm sorry, this is 0.02, no? This is not 0.2, okay? This is 0.02. This is 0.04. This is 0.06. It is 0.08. This is 0.1. Okay, this is 0.1 actually. Okay, 0.1, it is you again, you have 1 here. So 0 you have 1, 0.1 you have 1. So there are 1, 2, 3, 4, 5 cycles. Again after 5 cycles, you will have 0.2. Okay, again after 5 cycles, you will have 0.3. Again after 5 cycles, you have 0.54. So again you have 1, 1, 1 like this. Okay, I I I just mistake this decimal number. Okay, so again you will have 1, 1, 1 like this. Okay, previous time you get 0.5 values. Okay, so again 0.5, at 0.5 again you will have the 1 value. Okay, that means there are 25 cycles. After 25 cycles, you will get again 1. Again after 25 cycle, again you get 1. Okay, so again you will get 1 if you put 0.5. Okay, and if you put 0.1, again it will be 1. Okay, so one circle is 0.02. Okay, so you need to select the increment lower than 0.02. Okay, not 0.2, 0.02. So if I write this, so you can see that. Okay, so you can see that there are actually what happened here. Okay, so one cycle value is 0.02. So we have up to 4 seconds. Okay, so one cycle value is 0.2 seconds. Okay, so it has up to 4, 0.02. 0.02. This is one cycle time. Okay, this is one cycle time, and you have time up to 4 seconds. Okay, so 0 divided by 0.02. That means you will have 200 cycles. Okay, තේරෙනවද කිය මේ අච්චරට කොච්චර නම් මෙච්චරට එච්චරයි හරි තේරෙනවනේ කරන දේ නේ එක සයිකල් එකක් 0.2 නම් මෙතන තප්පර 4කට තියෙනවා සයිකල් 200ක් මෙතන. මෙන්න මේ ස්කේල් එකේ සයිකල් 200ක් තියෙනවා. මෙහෙම 200ක්. එතකොට ඒක එක ළඟින් තියෙන්නේ මෙහෙම. කොහොම හදාගන්න සයිකල් එක. So that is why we can't see this. So what you have to do? You have to reduce this time duration. Okay. So for example, so one cycle is 0.02. No? So 10 cycle, how many time? For 10 cycle, it will be 0.2. Okay, so if I draw our signal up to 0.2, only 10 cycles are there, not 200 cycles. Okay, so maybe now our graph will be clear. Okay, so now you can see that we have clearly see the cycle, but still we have a problem here. What is that? So you can see that now this is 0.1. Okay, so this is 0 point, it calculate the value. 0.1, it calculate the value. 0.2, again calculate the value. 0.3, calculate the value. 0.4, calculate the value. Okay, so 0.00, you have this value, and 0.01, you have this value. 0.02, you have this value. So these values are calculated. Okay, and it just join the line like this. Okay, so you will get somewhat like sawtooth signal. Okay, but triangle signal. Okay, so it is just like a triangle signal. Okay, so what you have to do is, if you get the values very nearly, okay, you can draw this signal very well. Okay, so what you should need to do is, you need more reduce the increment. Okay, then if you reduce the increment more, now you can see that, no, now it is look like a sinusoidal signal. Okay, now it look like a sinusoidal signal. Okay, so when you draw the sinusoidal signal, you need to be careful about number of cycles. Okay, so the easiest way is to calculate the one cycle time. Okay, calculate one cycle time. Okay, then select the time span for 10 cycle, only for 10 cycle. That is very good. Okay, very few cycle. Okay, calculate. What you have to do is calculate one cycle time. Okay, one cycle time. Okay, time. Then you need to calculate, you need to decide, you need to uh, decide very few cycles. Okay, maybe 10 or 15 enough. Okay, 10 or 15, not 15. Okay, 10 or 5 may be enough. Okay, so one cycle time into 10 or into 5, you can select this time span. Okay, so this way you can select the time span. Okay, select the time span. Okay, okay, so this way you have to select the time span, and also you need to decide the increment. So if you get very low increment, so your signal will be more smooth. Okay, but again, if you select in more values, it will take some time to draw. Okay, if you get big value, it will take some time to calculate. Okay, so if your signal look like a continuous time or sinusoidal signal, that increment will be enough. Okay, so that is how we generate the signal. Okay, now we need to sample the signal. Okay, for the sampling, you need to understand. I will quickly do that one also. Okay, give me 10 minutes. I will quickly do at stop the session. Okay, and I will so you can write this. So I will share this code with you. See, I will, after that I will share the codes. Okay, then you can save it somewhere in a Word document. Then you can copy paste it it on the MATLAB, and you can type. Okay, so but better if you can type this. Okay, rather copying and pasting. If you type this, it will so it will go to your mind. Okay, okay, okay. So now what I want to do is, I need to draw the discrete time signal. Okay, so what is the discrete time signal actually? The discrete time signal, that is x to n, is equal to cos, okay, cos 2 pi the frequency is there 50 is there, and instead of this t you have to put n ts. Okay, so what is n? That is nts. Okay, so I think you can remember we have put instead of this t nts. Okay, so now this n is, so here you have to define these two variables. Okay, otherwise you will get the error message. Okay, this n and ts not defined. Okay, so you can see that the n is not defined. Okay, so first you have to define the n. Okay, so define the n. N is the sample number. Okay, so sample number is an integer, plus or minus integer. Okay, but here you select the time from 0. The sample also will start from 0. Okay, so I will start from 0, and that increment should be 1 definitely. Okay, because that should be an integer, not a decimal value. Okay, so you can select some sample point here. Okay, okay, so this way you can define the n, that is the sample number. Okay, but now again you have to define this ts. Ts is what? You are given the frequency, the sampling frequency, that is 40. Okay, that is the sampling frequency. Then what is ts? Ts is equal to 1 over fs, 1 over frequency. Okay, so the same equation you have typed here. Okay, so if you run this, okay, so still I didn't plot this. Okay, so you need to plot this one also. Okay, you need to plot this one. Okay, so I can write plot. Okay, now independent variable, you so maybe you think that because ts is a constant, no, now the independent variable is n. Okay, so I will write n here. Okay, I will write n here. Okay, that is the independent variable. So dependent variable is x2n. Sorry, I need to I forgot something to tell. Okay, now you need to draw the discrete time signal. No? Okay, to draw the discrete time signal, normally how we draw the discrete time signal? Okay, so after we get in sample like this. Okay, so we get sample like this after this sampling the signal. Okay, so we have some voltage value like this. Okay, and there are some corresponding sample numbers 0, 1, 2, 3, so on, 4, so on. Then we normally show the sample number, sample value with the sample number. That is the normal way to draw a discrete time signal. Okay, so what we are doing, we have sample number from 0, 1, 2, 3, 4, maybe minus samples also may be there, -2 likewise. Okay, and we have different uh, different value like this. Okay, so you can mark these values using scatter command. Okay, this only if you need to mark only this point, you can scatter command, you can use scatter command. Okay, but here for normally for a discrete time signal we draw, we also join this corresponding sample value with the corresponding amplitude value like this. Okay, okay, like this we, like this, no, like this we show. Okay, using maybe sometime using a line like this. Okay,
Excuse me.
yes.
Only we can see some no can't see signal. Only see that some words only. You see some word document or something you written. ඒ නිසා අපිට මේක විතරයි පේන්නේ
Yeah,
මේ
yeah, yeah, I could understand. Yeah, yeah. So it is not shared. No. Mhm. Okay, I'm writing here. Okay. Okay, I will tell it again. Okay, so if we draw a continuous discrete time signal, normally we use sample number and the amplitudes level xn. Okay, so we mark the sample number 0, 1, 2, 3 likewise, and if we have minus sample, we also mark those values -1, -2, -3, so on. Okay, then we mark the corresponding amplitude value for the corresponding sample. For the relevant sample, we mark the corresponding value like this. Okay, so if you want to show this corresponding value only, you can use scatter command. We have already used them. Okay, only this value. If you use plot, this value will be joined. Okay, okay, but in for normal discrete time representation, graphical representation, we normally show this corresponding sample value also by joining this point and the sample value, this point and the sample value, this point and the sample value. This is normally we draw a discrete time signal. Okay, so that can be done using another command that is called stem command. Okay, you can check it in Google and see different syntax there. Okay, but I will directly type it here because now no time actually. Okay, because maybe tomorrow you have to go to work also now. Okay, so I hope you can see my MATLAB again, MATLAB uh, uh, screen again. Okay, so I'm now in MATLAB screen. Okay, so I hope you can see it. Okay, so if we use, instead of this plot, if we use stem command, okay, stem command. Okay, so you can use stem command. Okay, stem, you can use stem command. Okay, for discrete time signal. Okay, so discrete time signal, to plot discrete time signal. Okay, so this stem command is for step is discrete time signal. Okay, so it will show the corresponding amplitudes values and also join them with the corresponding time values. Okay, corresponding sample value. Okay, so if I run this, okay, yeah, this TS is capital S. No, here I use simple S. Okay, so this also should be capital, simple S. Okay, oh, this should be capital. Okay, so now if I run, okay, okay, now you can see that the corresponding value we can see, the corresponding value and corresponding sample value. Okay, we can see now that points are joined with each other. Okay, okay, now you can see that this is not the sample signal. Okay, the one thing is, another thing is, so here the first signal, continuous time signal, is not shown here. That is because it is first plot this, then when it plot this graph will be deleted. It is not in the same graph. Okay, so you have to use the hold on command. Okay, hold on command, this hold on command. Okay, so if you use this hold on, this will be there, and in the same graph you can see the, you can draw the this graph also. Okay, so if I run this, now you can see that, okay, the color is different. Okay, so you can see that here very small blue area, so that is actually our signal. Okay, that is actually the continuous time signal, and this is the discrete version. Okay, so the signal is wrong actually, you can understand it. So what is the problem with this? Okay, actually problem is that, so for this graph, this is the time axis, not the sample axis, time axis. Okay, so if you are going to draw the both signal in the same graph, okay, in both for both signal in same graph, okay. So this red color, that is our continuous time signal. It is in second, okay, and this the discrete time signal in sample number 1, 2, 3 like this, okay, and this time and samples are not mapped actually, not matched, okay. So we have to match the sample number with the time, okay. So that is we have to do, okay, otherwise we can't get the corresponding value, okay. So what you have to do is you have to map that sample value, that TS, okay, the sample time, that is the corresponding sample time using this equation, okay. So now I have get corresponding sample time, okay, for this corresponding sample value, okay. Now when I plot this, okay, so I have to use this time value corresponding sample time, okay, not the sample number. Sample number is 1, 2, 3 like that, okay. So it is independent from the time, okay. If I use just in 1, 2, 3 like that, it will be not match with the time, okay. So you have to match with the time and you have to plot the same graph in time domain, okay. So this is the sample number corresponding sample time, okay. This will be the corresponding sample time, okay. So if I run this, okay, so you can see now we have some kind of progress, but still the signal is not there, okay. So what is happening actually here? So now you can see that we draw our signal up to 0.2, okay, but TS, if you consider this TS value, so it is go up to, because 100 values are there, 2.5, okay. So here we have we get our signal up to 0.5, 0.2, but it extend, the time is extend up to 2.5, okay. So this is 0.5 around here, okay. So up to this level we can see the signal up to 0.5, okay, 0.2, this is around 0.2, then but up to 2.5 you have the time values, okay, that samples values, okay. So we no need to go up to this level. If we limit our x-axis to this value, that is enough, okay. X-axis is this value, that is enough, okay. So I am going to limit the x-axis, okay. So that is my approach, okay. So you can so there are many code available for the for sampling, okay. So you can use any one, but this is very straightforward, okay, because we use every points that we have learned, okay. So we can limit the x-axis using this command, xlimit command, okay. So first within this bracket you have to put the beginning value and the starting value and the ending value, that is ending value is 0.2, okay. So now if I run this, okay, so you can see that now the x-axis is limit up to 0.2, x-axis is limit up to 0.2, okay. And now you can see that, so you can see that these are the sample, okay. So this is one sample, this is another sample, right, this point, yeah, this one, okay. So you can see that, okay. So this is our first sample, this is our second sample, this is our third sample, This is our fourth sample. Sorry, this is our first sample. This is the second sample. This is third sample, fourth sample, fifth sample, sixth sample, seventh sample, eighth sample, so on. Okay. So this way we can get. Okay. So this is the sampled signal. This orange color one is the sampled signal. Okay. So you can compare the corresponding value, corresponding sample point with the actual sample point. Okay. So maybe you can remember that the sampling frequency is 40. So what is the one sample time? That is 1/40. This is the sampling time. So it will be 0.025. Okay. So if you get first sample here, after 0.025, you need to get the second sample. Okay. So you can check it. Okay. You can go to this tool and you have this data cursor. Okay. So using data cursor, maybe you can see here. If you click here, okay. So that this is the second sample, that is 0.025 now. Okay. Third sample, second sample after again 0.025 value. That means it will be 0.05. Okay. So this sample. Okay. So this should be at 0.05. No? This value, X value is 0.05. Okay. And if you find this one, again it after 0.025 time. So it will be 0.075 like this. Okay. So so you can see now you can see that our program is correct. Okay. And if you increase the sample number, for example, if you select 50 for the sampling frequency, and if you run this, okay. Okay. So you can see that now this is your sampled signal. Okay. This is the original signal. Now you can see that the sampling time will be 1/50. That means 0.02. Okay. So first sample it get at 0. So same way you can go to the data cursor and check. Okay. So this is 0, 0. Then after 0.2, 0.02, you get next sample. Okay. So this will be at 0.02. So this will be at 0.04. Okay. Likewise, you get other samples. Okay. Okay. Now, okay, we will stop now. Okay. We will stop now because time is running out. Okay. We are running out of time. Okay. So you can see that if we increase the sampling number, sample frequency, okay. If we increase the sample frequency, okay. So you can see now, we put sample frequency as 0.100. Okay. 100. No, we select the sampling frequency 100. That means what is the sampling time? 1/100. That is 0.01. Yes, 0.01. Okay. So this is the first sample. It take at so it take at 0. Okay. The second sample, it should be at 0.01. Okay. So this will be at 0.01. Yeah, 0.01. Okay. This should be 0.02. This should be 0.03. Okay. So please understand one thing. Okay. So you can see that when the frequency is doubled, okay, when the frequency is double, you can see that here we have one sample and here we have one sample like this, okay? So if you reconstruct this signal using the analog digital converter, digital to analog converter, you will get this kind of signal. This kind of signal, it is somewhat equal to this sinusoidal wave, but not, it is not a sinusoidal signal, it is a triangle signal, but it is up to some level that will be okay. Using maybe signal shaping, we can achieve this sinusoidal variable, sinusoidal variation, okay? Okay, but if you reduce this signal, for example, for 50, if we take 50, okay, if we take 50 sampling frequency, okay, so you can see now you can see that here this is one sample, this is the second sample, this is the third sample, so on. Okay, so once you reconstruct this, you will get a DC signal like this, okay? Actually not a DC signal, you will get this kind of one, okay? Because it is also depend on the resolution of the signal, resolution of the circuits, okay? So generally we can assume that you will get a DC signal like this, okay? Not a sinusoidal signal, okay? So what you have to, if you want to regenerate a good signal, you need to increase the sampling frequency. For example, if you increase the sampling frequency very high, okay? If you increase the sampling frequency, okay, now you can see that one sample here, one sample here, one sample here, so on. So you can get somewhat clear, okay? So if you get more sample, more sampling frequency, okay? Okay. So again, we have a problem because now samples are running out of time, okay? Now we have sample. Now, actually we select only 100 samples. No, if you get a very high sampling frequency, that means there are a lot of sample we get within this duration. Within this duration, lot of sample we have. Okay, so we are running out of sample. So what you have to do is you can increase the sample value here. Okay, then that problem will be solved. So maybe you can't understand what I am saying. Okay, you have to do this and check this, then you can understand. Okay, so you can see that now we get very the sample point from very nearly we can get the sample point like this. Okay, so when you construct this signal, it will be very smooth signal. Okay, so if we increase the sampling frequency, the reconstruction will be very smooth and very easy. Okay, so that is the idea you should get. Okay, if we increase the frequency, sampling frequency, this one, okay, if we increase fs, okay, fs, the reconstruct the signal reconstructed signal reconstructed signal will be more smooth and accurate okay, so you need to understand this point also. Okay, so maybe this point you have understand. Okay, can you remember that we have learned that point, that is the Nyquist sampling theory. Okay, so this is according to the Nyquist sampling theory. The Nyquist sampling theory says that the sampling frequency, this fs should be at least twice than this signal frequency. Okay, so that is the sampling, Nyquist sampling theorem. Okay, so if we increase the sampling frequency, so the reconstruction will be very easy. Okay, so we will stop here. Okay, so we need to discuss the Eliasing effect. Okay, next week. After Eliasing effect, after discussing Eliasing effect, we will move to Fourier transform part. Okay, Fourier analysis part. Okay, so maybe after next week we can move to the Fourier analysis part. Okay. Okay, so now we will stop. If you have any question, you can ask. Okay, so maybe you haven't understood this very well. Okay, probably. So if not, you can later ask me by sending a message or sending a WhatsApp message or calling. If you have any problem, please ask me. You can call me or you can ask. No problem. Okay. So if you have any problem that at this level, you can ask. If you haven't any problem, you can leave, no problem. I will be here around 5 minutes. If you have any problem, you can ask. Otherwise, leave. Okay. Good night.
අපිට වීඩියෝ රෙකෝඩින් එක එවන්න පුළුවන්.
රෙකෝඩින් එක මම කලින් ඒවට දැම්මේ නෑනේ.
ඔව් සර්.
හරි මම දාන්නනේ රෙකෝඩින්. තුනම දාන්න. අද ඒක නම් කචල් හැබැයි. මේ මොකද 3කට 4කට රෙකෝඩ් වෙලා ඇත්තේ.
ඔව්.
මෙහෙමයි ඔකට අද ඒක තේරුණා නේද? මම කලින් කරපු රෙකෝඩින් එකක් තියෙනවා ඔය
තේරුණා සර් මුල් ටිකේ මම හිතන්නේ මේ අපේ graph ටික දැක්කේ නැහැ මොකද මම හිතන්නේ සර්ගේ page එකේ මම හිතන්නේ මේ
එහෙමද? හරි සාමාන්‍ය මට්ටමකට තේරුණානේ මේකනේ.
ඔව්
සාමාන්‍ය
ප්‍රශ්න
ජෙනරල්. හරි.
සර් ඔක්ටේව් කියන එක පුළුවන් නේද මේ
පුළුවන්. ඒකනොත් පුළුවන්. ඒක අර නිකන් මේ ඔන්ලයින් version එක වගේනේ MATLAB වල.
ඔව් ඒකෙන් ප්‍රශ්නකුත් නැහැ නේද?
ප්‍රශ්නයක් නෑ. ඒකෙන් කරන්න. ඒකෙන් කරන්න පුළුවන් නම් හොඳයි. එතකොට MATLAB install කරගන්න ඕනෙත් නෑනේ. හැබැයි වැඩේ තියෙන්නේ ඔක්ටේව් වල සමහර වෙලාවට ඔය මේ ඔය මේවා කැල්කියුලේට් කරනකොට සමහරලාට මේ පොඩි errors එනවා. මට අහුවෙලා තියෙනවා. ඒක හරි හොඳ version එකක් ගත්තා නම් හරි.
මම බලන්න සර් මොකද මගේ එකේ MATLAB මේ කරන්න විදියක් නැහැ Chinese මේ display language එකක් තියෙන්නේ. ඒකෙන්ද පොඩ්ඩක් අමාරුයි.
හරි කමන්නේ. ඔක්ටේව් වලින් කරන්න ප්‍රශ්නයක් නෑ. මේ මොකද කලින් ළමයි කරා එතකොට මේ ආවා එක errors. කමන්නේ මේ අවුලන්නේ නැහැ. හැමෝටම ආවේ සමහර කට්ටියට විතරයි ආවේ. හරි? මේක ඔය කට්ටියට දැන් අර සාම්ප්ලින් කරන එක සම්පූර්ණයෙන්ම තේරුන්නේ නැතත් හරි ඔය කට්ටිය නිකන් කෝඩ් ටික ගහලා බලන්න තේරුම් ගන්න බලන්න අර මොකද්ද කරේ කියලා. මං ගාව තියෙනවා වෙන රෙකෝඩ් කරපු එකක්. මං හිතන්නේ ඒක සාමාන්‍ය මට්ටමක හොඳට තියෙනවා. මං ඒක දාන්නම්. හරි? මං ඒක දාන්නම් මේ මොකද දැන් මේක දාන්න
අපේ ඇදලුනොත් ලබන සැට් එකක් හරි කරගන්න පුළුවන් නේද?
මොකද?
ඒ කියන්නේ අපිට අපේ ඇදලුනොත් එකක් කරගන්න පුළුවන් ලබන සැටේට වඩා එකක් ක්ලියර් කරගන්න. ඒ කියන්නේ අපි කරන
පුළුවන්. අවුලන්නේ. හරි? right අපි කොහොමද දැන් ටක් ගාලා මේ අර සාම්ප්ලින් එක ඉවර කරන්න ඕන. දැන් පටන් ගන්න ඕන ටක් ගාලා මේ වලට ඒක. හරි? හරි අවුලන්නේ. ඔය කට්ටිය දැනට අර ડોක්ටර් උදේශ්ගේවත් නිකන් සාමාන්‍යයෙන් බලනවනේ නේද රෙකෝඩින් එක.
ඒකේ රෙකෝඩින්ස් තියුන්නේ නැහැ. හැබැයි මගේ ගාව පරණ ටික නම් තියෙනවා.
හරි මම පොඩ්ඩක් බලන්න. රෙකෝඩින්ස් බලන්න අපි දාන්න. හරි? අප්ඩේට් කරන්න. හරි. හරි.
එමස අපි ලිව් වෙන්නද?
හරි ලිව් වෙන්න. හරි. thank you.
thank you sir. හරි good night.
හරි okay. hello. ෆෝන් එකයි මම කිව්වේ මේ